Hi. About a year ago, I made a video about a project I did in Minecraft. It was about a blackjack machine that I did entirely in redstone, entirely in survival. There was no tutorial that existed for it, yada, yada, yada. And the video didn't do super well, which is totally fine, by the way. I'm not really trying to be a hardcore YouTuber, much less a Minecraft YouTuber. I don't really know that much about the game. But anyway, yeah, I basically had just made the video to document the process, have something out there because I thought it might be useful for someone else trying to do a similar project. And it was. Well, sort of. I got a message on Reddit recently that someone had a bunch of questions for me about how it worked, and they were asking if they could have the world file. I actually don't have the world file to share since that was done on a server that belongs to one of my friends. So I'm making this video. Like the last video, this is also not necessarily going to be a tutorial. It's more just a series of lessons that I've come to learn about digital logic that I learned from that project and from some other ones. Because if I'm being honest, I don't think tutorials are actually that helpful. If you teach a man how to build a specific redstone thing, they will be able to follow your tutorial and make that redstone thing. But when it comes to actually doing other stuff in redstone with digital logic in general, they're not going to have really any idea what they're doing. That's how the expression goes, right? This video is going to be mostly about digital logic and circuit design, not super Minecraft heavy, not super redstone heavy. I'm going to touch on that in brief parts, but it's really not the main focus of this video. Okay, so there are a couple of prereqs before we get into this. The person that I was talking to in particular said that they're already familiar with a lot of basic digital logic stuff in Minecraft, for example, registers or adders, binary comparators. That stuff is all super good to know. You'll definitely need it going into this. I would recommend Matt Batwings on YouTube. He makes some really good content on digital redstone. If you're doing this in survival, you are going to need a lot of redstone. I would recommend making a witch farm. I tried mining for it by hand at first, and it just took me forever. So just make a witch farm, AFK there for like literally 2 full Earth days. And come back to it. Even if you are doing it in survival and not creative, I would definitely recommend prototyping your designs in creative, kind of mapping them out, making sure that it's going to work as you're intending it to before going into your other world and actually implementing it. With that, let's go to the drawing board, and here we are. So I think a good place to start would be looking at the basic requirements for getting a blackjack machine working. So what do we need? First, why don't we take a step back and imagine a simpler computer, a computer whose job is just to simulate drawing one card. So what goes into a computer like that? Well, first off, you will need a random number generator. We're going to need a register to hold the drawn card. We are going to need a register for the hand that we're adding the card to. And we're going to need an adder to add the card to the hand. So I just realized the term register is a bit nebulous. It can mean different things depending on context. So to be clear, here's what our registers do. Our registers store some amount of bits either as SR latches or T flip-flops or whatever. That's not really important for the sake of this video. They accept some input like this. Just came up with a random number, and given some input, you're allowed to change the register to that value. So if we have this input and we press set, then the register becomes this. Pretty simple. Then to clear out the register, all you would have to do is set all of these to 0, hit set, and then you would have an empty register. All right, now let's fill in the blanks for how these are actually connected. So obviously the random number generator goes to the card register. The card register goes into the adder goes into the hand register, and now the hand register, in order to add the card to the current value of the hand, feeds back into the adder. Okay, so then how do we draw a card? First off, let's set up our base state. So we're going to start off with both the card register and the hand register being all zeros for both. Then let's say we use the random number generator and we generate the number 4. This is 4 in binary. 4 plus 0 is 4. So we generate a number using the random number generator. We write that number to the register. And for now, the hand is still at 0. Let's add another column for the adder. All right, so now, because the adder takes in both the card register and the hand register, its current output value is going to be 4, because 4 plus 0 is 4. Now that the adder has the correct output value, we will set H to the current value of the output. So this doesn't change anything about C. This sets H to the current value of add, so 4. And then adder is actually going to change to 4 plus 4, which is 8. And that's it for drawing a single card. What if we want to draw another card? Well, first, before we do anything, we have to clear out this register. So we'll do clear C. Then we'll generate a number. Let's say we drew a 10, because 10 is the most common number that you see in blackjack. Oh, I did not mean to do that. All right, now we have C. The most recently drawn card is 10. The current value of the hand is 4, and the value of the drawn card plus the hand is 14. So now we'll set H. Remember, we're setting it to the output of the adder. Doesn't change C, does change H, and then this kind of doesn't matter. I don't know, I'm just too lazy to do the binary addition. Okay, but this is how our simple card drawing machine works. Okay, so now let's see if we can try to make this work in our overall blackjack machine. Like before, everything starts with our random number generator, which feeds into a temporary register just for the drawn card. And now, let's try to think about the opening procedure of the game, for example. When you're starting a game of blackjack, first you deal each player an up card. So we'll just say deal player. Then you deal the down card, or the secret card, for the dealer. Then you deal another card for the player, and then you deal the dealer's up card. Now, this works exactly like our example from before, just showing the simple card drawing machine. The only difference is that we're going to switch the target register for which one we're adding to. All right, so this is pretty similar to before, except now we've introduced this switcher to decide which register we feed into the adder. So if we're drawing a card for the player, first, we toggle the switcher to output the player number. Then, once the card has been drawn and added through this adder, we set the player register. Okay, once we've done these 4 steps, then we need to decide what happened. Whatever. And you know what's really helpful for deciding things? A decision unit. Okay, what exactly do we mean by decision? Well, basically, after we've done the opening procedure, we need to decide what happens next with the game. For example, did the player get a blackjack? Did the deal... I'm just going to write these down. So here are all the different outcomes after the starting procedure of the game. We can either have a normal game, that is, nobody got a blackjack, the player got a blackjack, the dealer got a blackjack, or both got the blackjack, which means it's a tie. How do we actually check for these conditions? We use a binary comparator. So first off, let's have these be our different inputs. We have the player register, the dealer register, and the secret register. In order to see if the player got 21, we have some comparison. We're going to feed in the player, and we're going to feed in the number 21. So this will output true, a 1, if the player equals 21. How do we tell if the dealer got blackjack? Well, first, we need to add together the dealer up card and the dealer secret, and then we do the same thing. Compare equals 21. And now we have 2 Boolean values that we can do to create a truth table. We'll call this A, and we'll call this B. So A equals player blackjack, and B equals dealer blackjack. So if A equals 1, then the player has a blackjack. If B equals 1, then the dealer has a blackjack. So here are all the possible values. If nobody gets a blackjack, it's a normal game. If the dealer gets a blackjack, you lose. If you get a blackjack, you get a blackjack. And if both of you get a blackjack, then you push. There's a few other scenarios when we'll also need to use our decision unit. For example, we can check if we bust by comparing the player register to 21. If the player register is greater than 21, then we bust. But if we're equal to 21, then we should stop drawing entirely. We also need to decide if the player beat the dealer at the end of the game, assuming that nobody busted and instantly lost, who actually had the higher value in the end. Now, if I recall correctly, the comparators actually output 2 flags, one for whatever this value is, and then one for equal. So you can use it to get all 3 potentials. Either they're equal, greater than, or less than. This isn't really a piece of digital logic advice, just a piece of like general logic and procedure advice that I think would be really useful for someone who doesn't have a computer science background or hasn't really done projects like this in the past. And that is making flowcharts for your work. It can really help to understand how your process works at the most fundamental level if you do this. There's tons of videos on this, so I'm not going to dwell on it too much. You can learn how to make flowcharts online. It's pretty simple, but I'll just do a simple one for how to draw a card. So first, this is just our starting point. First thing we do is generate a number. Next, we're going to write that number to the temporary register, the card register C. Now, let's assume this is the player drawing a card, just for the sake of example. So for the player, we're going to make sure to set the switcher to P, just to make sure we are targeting the correct register. Once we've done that, and the value of P has been added to the adder, and so is the value of C, we are going to set P to adder result. If we're drawing a card though, then there's a chance that we could bust. So what we have to do is say P greater than 21, question mark. For branches or decisions, you make this diamond shape, but I always have a hard time drawing these, I don't know why. If yes, the player is greater than 21, then player bust, you lose. Okay, if the player is not greater than 21, what about equal? Are we equal to 21? If we're equal to 21, then as a courtesy, we will just automatically make the player stand on that. Otherwise, if we're not greater than 21, we're not equal to 21, then that means we're less than 21, and we'll let the player make the decision. This shape means you are waiting for some input. If the player chooses to hit, then we go back here, and if they choose stand, then obviously we go here. And that's it. That's the flowchart for drawing a card for the player. This is how the general loop of the game works. Now, if we're being really nitpicky, the game actually doesn't start here. The game starts here, because once the opening procedure is done, the player gets the decision to hit or stand. Or if there was a blackjack, they would just, or one of the other cases. This is the flowchart for how normal play works in the game. And you can go as wide or as detailed as you want with these. You could say, instead of generating a number, you could be talking about, the specific button you have to press, the signal that goes out. You could be talking about how the random number generator works specifically. You could talk about zeroing out this register, whatever mechanics you have to do there. Whatever is going to be easiest for you to understand, I would highly recommend making one of these to help you break down the process into smaller steps and understand the parts of it that are most challenging for you. And that's about it. So there are some Minecraft specific difficulties when it comes to designing the system. The number one that I ran into was latency. It takes a long time for the signals to come from the control panel to, the guts of the actual machine and everything. On top of that, you need to know exactly how long you need to wait for things like a card draw. How long does it take to draw a card? How long do you have to wait before safely drawing the next card? For mine, I just have, honestly, it's not a very good system. I just have a series of very specific waits from repeaters, knowing how many ticks it takes to do certain things. But this is something that you should experiment with, try out. I think in the video I also showcased my method of, waiting for a certain signal to come. So after a card is drawn, we emit a redstone signal that says, hey, a card was just drawn, and there might be a circuit somewhere that is waiting for that to come in. It hits that, and then we send off another signal to do a certain task. So that's like the correct, proper way to handle async. But yeah, basically what I'm trying to say is the way that I implemented it was very imperfect. And if I were to start from scratch, I would start with this top-down holistic approach to it. And yeah, the thing is, I just didn't know when I started that project, A, how big it was going to be, how much work it was going to take, and B, the appropriate way to design it. With that being said, to the guy on Reddit who reached out, good luck. I hope this video was informative and helpful, and who knows, maybe someone else will get a kick out of watching this too. If you still need more help with this, or anyone needs help trying to figure this out, I'll see what I can do. Again, I can't really share the world file. Maybe I could make a prototype or something in creative, and or just do another tour video, something like that. Let me know. But yeah, that's Swan out.